Fashion Week continues. Still trendy. Oh, hey, want to see a meme? Have you seen Chemistry Cat? He says, why were the kids wearing periodic table shirts? It was trendy! Look, I don't think this cat has arms. It's kind of weird. Alright, so within a group. Last time it was period, right? Now it's group, so it's up and down. So in the noble gases, I remember the noble gases are inert. I remember that. They're all the way on the right. So helium is the smallest one. So this is actually going down. So going down. And so as I'm going down, those are basically the same size. I mean, 0.49, 0.51. And then they get bigger. So going down, radius goes up. I guess I should say going down the periodic table, right? The radius goes up. We got to be specific. Electronegativity in group 1. That's interesting. It's not noble gases. Actually, I noticed that last time too. I don't know if the noble gases have electronegativity. Huh. Okay. So in group 1 it goes hydrogen, lithium. Yeah, so this is down, right? So as you're going down, the electronegativity is going down. So down the periodic table, electronegativity goes down. And then here is going down the periodic table this way, and the ionization energy is going down too. So electronegativity, ionization energy both go down. Atomic radius is going up. Okay, same thing as last time. Pause the video, answer these questions. I'm gonna tease you if you don't do it for, in class. I'm gonna be like, what's the matter with you? You can't pause videos? Reading. How do scientists, that's you guys, sort of, explain the patterns in atomic radius, electronegativity, and ionization energy that we have observed? I bet you have something to do with the atom. As it turns out, scientists have been able to explain these patterns using only basic atomic structure. So I'm thinking, protons, neutrons, electrons, nucleus, stuff like that. Within a group, so yeah, it's up and down. Up and down is a group. On the periodic table, these are also called families, right? Groups or family. We can explain these patterns using the number of shells. Last time it was protons, now it's shells. As you move down the periodic table, the atom has more shells. I'm looking at this, and yeah, that's obvious, right? 1, 2, 3, 4 shells. Number of shells is increasing. So as you move down, each atom has more shells. Atoms are getting bigger. Yeah. Well, yeah, they're getting bigger. Electrons are further from the nucleus. Yeah, so... Well, I mean, they're not all further. Just the outer ones are further. The electrons feel less attraction from the nucleus. But really, it's just like the valence, right? I mean, that's got to be what it means. I'm not 100% sure, but they can't all get farther away, because those ones look like they're the same. Anyway. Electrons feel less attraction, so electronegativity goes down, and it's easier to remove electrons. Well, yeah, if they're less attracted, then it's going to be easier to take them away. Let's read through this. So the more shells an atom has, so that means lower on periodic table, the larger its atomic radius is, since each shell is larger than the previous. As the shells become larger, electrons on the valence shell, oh yeah, so it was just the valence shell, are farther and farther from the nucleus. So the electrons feel less attraction, right? Because, I mean, if this is your nucleus and you've got an electron right here, it's going to feel a lot of attraction. But if you've got one like all the way over here, it's like long distance romance. It just doesn't work. This electron's like, see ya. Right? They feel less attraction from the nucleus. So electronegativity decreases. Since the electrons feel less attraction from the nucleus, it's easier to remove the electrons from the atom, and the ionization energy goes down. Take a look at the check your understanding questions. Make sure you're ready to discuss those in class. And make sure you actually filled in these blanks. I mean, really. I'll see you in class. Stay beautiful.